Hi there, welcome to the first Math Olympiad training. Thanks for taking time to watch this video. The main objective of this video is to help you understand how to solve Math Olympiad questions more easily. If you are unclear with anything in this video, feel free to ask in the comments section. Remember to click on the like button and share the video to anyone whom you think will benefit from this. Okay, let's start. Working with whole numbers is a key component of Math Olympiad. To understand the content of this video, you need to understand basic algebra. If you are not familiar with algebra, you can learn algebra from the links provided in this video description or from the numerous algebra tutorials out there. Some examples in this video are taken from this book titled Math Olympiad, Unleash the Math Olympian in You by Terry Chu. The link for this book can be found in the video description below. I find the examples in this book quite useful, but it may not be easy for some to follow. Hence, I will go through some typical Math Olympiad questions on whole numbers in this video to help you better grasp the methods that can be used to solve such problems. Working with whole numbers. Firstly, you need to understand how whole numbers can be represented using algebra. Let's take the example here. 1, 2, 3, 4 is equals to 1000 multiplied by A plus 100 multiplied by B plus 100 multiplied by C plus 1 multiplied by D. So what is A? As you can see, A is 1, you can guess, B is 2, C is 3, and D is 4. How does it work out? It is actually, because 1000 times 1 is give you 1000, 100 times 2 give you 200, 10 times 3 give you 30, and then you get 4. Yeah. Next, you can try 543 yourself. You may pause this video if you wish, or you can try out. Okay, let's go through this example now. 543 can be represented using 100 multiplied by 5 plus 10 multiplied by 4 plus 3. Okay, it gives you 500 plus 40 plus 3. This is a very important concept that you will need to solve Math Olympics questions going forward. Okay, let's work on the possible Math Olympiad type of questions here. So you have 999,999 multiplied by 222,222 plus 333,333 multiplied by 333,334. So how do you solve this problem? Alright, so firstly you need to see that, okay, is there any way to simplify this? Okay, usually when they set such a question, there must be a trick somewhere that you can use to simplify it. Right? If not, how they can't expect you to use a normal multiplication to solve this type of problems, right? You can't possibly solve it. Alright, so there must be a trick. So what happens is that, look, there's a common multiple here. Okay, 909,909 is basically just 3 times of this number, isn't it? So you just write this way, alright? Multiply by 222,222, and then you will get this, okay? Next, you can then bring this 333,000 out, right? And inside you have this left, okay? Alright, and then you bring this number out, right? So what you do is that this is a very basic algebra, right? I don't think, I mean, you should know, but never mind, I'll just show it here. So basically, let's say you have a number here, right? Say A, okay, multiplied by B plus A multiplied by C. So to simplify this, okay, you take out the A, right? You take out the A, right? And then you have B plus C. Alright? So equals to right, so basically you can simplify. So A in this case here is this part here. Okay. So it's the same principle basically, okay? So you have A, which is the 3,333, and then you have this, right? So it's the same principle. So once you take out this number, then next what you can do is 3 multiplied by 222,222, you get 666,664 plus 333,334. This number becomes what? 1 million, right? Okay. So when you have 1 million multiplied by something, as you know, it's very simple then, right? You just take away 1 and then you have how many zeros behind? 1, 2, 3, 4, 5, 6, right? So this 12-digit number solution, but it's not too difficult to solve actually. It's quite standard problem. Okay, before we proceed further, let's look at some simple math shortcuts. You have 2,200 minus 22 here. So how do you do this? Solve this problem? Actually, there's a fast way to solve this problem, but let me show you the difficult, the long method first, right? Of course, if you don't know the tricks, what you will do is you have 2,200 minus 22. You write this, and then you have firstly you bring over this, then you have this, then you have 9, then you bring over this, then you have 8, then you have this 7, then you do 1, 2, 2, right? But do you notice the pattern? Okay, let's look at the next number. What about this? I think the pattern is quite similar. It's quite obvious here, right? You would have you always end with an 8, right? And then the 2's here will retain, alright, and then the middle one will have a 1, because there are 3 digits here. It means the 3 digits here will change. The next one will be a 1, and then followed by 22. Okay, so for example, over here you have 2 digits here, right? So you have 78, and then that's followed by a 1 and then a 2. So let's do an example here. Can you tell me the answer? I think you know, right? I think it's you can write it down, take a minute or two, or you can pause the video, just write the answer. Okay, it's very simple. Again, down here you can see over here, right? You have 4 2's here, right? You have 4 2's here. So there'll be 7 7 8, 3 7's and 1 8, followed by a 1, and this one is this one here, and then you have retained the 3 2's ahead in front. Alright, so this is the principle of minusing 2's. Alright, next you will have 3,300 minus 33. So again, if you want to see the math behind it, you don't know the tricks, you will have to do this, right? So basically you have 2 minus cancel 1, 9, 1, so you get 7, you think, oh, you get 6, then it's 2, 3. So remember, alright, you can see that the 3 here will always end up, the last digit will always be a 7, right? The last digit will always be a 7, and after that there will be 6. Okay, so it's the same thing here. You can see the pattern. Alright, so you can try this thing here, right? Okay, 300. Okay, sorry. You can try this thing here. 333. 1, 2, 3 minus 3, 3, 3. Alright, you have 2. So you know there's going to be a 2 here, right? Then you have 9. So you know there's going to be a 6, right? You don't need to carry again, so there will be another 6. So there's only a 7 here, right? So you know that you have 2, 6 here. The last one will give you a 7, right? The 10,000s will give you a 2, and after in front there will be no changes, right? Okay, with the simple subtraction tips that you gain from this, now we can proceed to the real question. Okay, you have to find the sum of all digits of this. Okay, what this means is there are 2008 threes here, and there are 2008 6 here. Okay, so how are we going to do this? I'm like, okay, how are we going to do this? Alright, it's not easy if you first time come across, but actually there are some tricks. Right, there are some tricks. Right, all these problems, there are some tricks. So what you do is, you know that okay, I want to firstly try to make this number easy to work with. One of the numbers have to be easy to work with. So I split 3 out here. Why I split 3 out? Right? Because what I will get is, I will get 3 multiplied by this, right? If I have 3 here multiplied by this numbers here, right? Multiplied by this number, I'll get all the 9s, right? I'll get how many 9s? I'll get 2008 9s, right? Alright. Okay. And with this, you will be able to let me just erase this part here, right? So that doesn't mess things up here, so messy. So what you do after that, you will have you don't get this number here, right? So you have a string of zeros here, 2008 zeros minus 1. Okay, this is just a math principle, right? You said, it's just like a number minus the number, okay, multiply by c. What you do is a c minus b c, isn't it? Okay, so you know that this 2008 2's multiplied by this 2009 digit number here, you have how many zeros behind? 2008 zeros, right? 2008 2's here. So what you'll get is this number here, right? And when it's deducted, as we go through earlier, can you guess how many 2's there are and how many 7's there are here? Okay, just now we learned, isn't it? Just now we learned. Remember the principle? Okay, try to work it out yourself. If not, can give the answer. They're going to be 2,007 twos, and they're going to be 2,007 sevens, right? Because there's an 8 here and there's a 1 here, right? Remember the example that we gave you earlier. Okay, so with this you will have you want to sum all the digits up, right? You can see that the 2's and the 7 add up to 9. Okay, so you know there are 2,007 of this. Okay, so you have 2 plus 7 here, right? So a pair of this 2,007. Then down here you have this 1 here and 8. You add these two up, it's also 9, isn't it? So you have one more pair of 9. So one more pair, so you have one more 9. So how many 9s are there? Right? So you have 2,007 plus 1 gives you 2,008. 2,008 9s. Alright? So when you have 2,008 9s, so what happens? So you can find the sum. 2,008 9s times 9. So the sum is 18,072. So by adding all these numbers up, you get 18,072. Okay, let's solve this problem here using algebra. The sum of 3 digits is 21. So what do you mean by sum of 3 digits? Sum of 3 digits is, for example, you have 1, 2, 3. So sum of 3 digits, sum of 1 plus 2 plus 3, in this case 6. Okay. Then the digits in the ones place is greater than the ones in the tens place. So ones place is here, but the tens place, so in this case it works, right? Okay, so this is okay. Okay. The new number is 198 more than the original one. Is formed by interchanging the digit in the ones place with the digit in the hundreds place. So this means they are trying to say that you are changing the ones place with the one in the hundreds place. So for example, it will be 3, 2, 1. Here one doesn't change. But you have 3, 2, 1 minus 1, 2, 3. Okay, it doesn't give you 198. It doesn't give you 198. Right? It doesn't give you 198, so this is not the answer. But the answer, it must give you 198. 198. Alright. What is the original number they want to know? So let's represent the 3-digit number with ABC first. Right? And guess the number. Can you guess? I think you can guess what is the original number, right? It's actually with the first sentence you can really guess, isn't it? So for example, you will have 8, 9, will give you what? 17. 17, then you want to give you 21, 4, right? So we give you 21, right? So 6, 7, 8 is a possible answer. So you get 6, 7, 8 because you want to interchange it with these two numbers. So it becomes 8, 7, 6 minus 6, 7, 8. This one give you 8, right? So you get 9 and this give you 1. Okay, so 6, 7, 8 is one answer. Whereas in this case it doesn't, right? In this case it gives you 9, 8, 4 minus 4, 8, 9. It doesn't give you 198. Okay? So 6, 7 is one answer. But is it the only answer? So basically what happened is that you have to write one equation here. 100a plus 10b plus c equals abc. What does this mean? Okay, again this is a very, just now I explained before, I will go through again. Alright, then you have so basically what happened is that you have this ABC here equals to this thing here, right? So substitute inside, you get an equation here, solve the equation, right? So substitute, this one is just this one, okay? Now you have A, this one, and then the 100C minus 1C here. So what happens is you get, what do you get? (99C minus 99A), because the B's got cancelled, right? The B's got cancelled, okay? So you have take out 99, right? It's common again. This is simple algebra to get this. Then you have C minus A divided by equals to 198 divided by 99. You get 2, which means that this simply means, and this simply means what? This simply means the ones is greater than the hundreds by 2. Okay, so you see 6, 7, 8, the ones is greater than the hundreds by 2. So 6, 7 is one answer, it's correct. But is it the only answer? Why don't you try 7, 8, 9? Because you have to have, because you want to have ones is greater than hundreds by 2, and this thing adds up to 1 as well. You switch it around, 5 is minus 7, 5, 9. What do you get? 8 here, right? 9 here, and because moves it here, now here become 4, right? Because it's carried over, so the 198 as well. Okay, so the other answer is 7, 5, 9, and one answer is 6, 7, 8. Right? So there are two answers. Okay. Okay, let's go through this example here on the application of algebra. Miss C was born on the 1st of January many years ago in 2002. Her age was the sum of all the 4 digits of the year that she was born in. How old was Miss C in 2002? So what does this mean? This means that if Miss C was born in 1937, then you have 1 plus 9 plus 3 plus 7, which means that it's 20. Okay, this is called the sum of all 4 digits of the year. Okay, so how old was Miss C, right? So again, you can express the math in the kind of equation that we have just learned. Okay, because she cannot be born in year 2000, right? She cannot be 2 years old. So because they raised it many years ago. So it can be 19 something, right? So express it in this equation form. Right now. Because they say anything that is 19 whatever, okay? 19 let's say 54, whatever it is, so it's like 1005 to 900 to 50 and then plus 4, isn't it? So this is, in this case, this is 9, in this case this is 5, and this, in my example here, this is 4. Got it? Okay, so again, this is just a recap. Alright, then you have sum of age equals sum of digits that the year she was born in. So basically you have this one here. This is the equation of the year she was born. So you want to find somebody's age, right? You take the current year minus the year, the birthday, right? So let's say if you are born in the year 2000, right? Then you're 2 years old, right? So this is just a representation. So in this case, it is, say, you're born in 1999. and they're 3 years old. Got it? Okay, so just a representation, alright, of the 1000. And this here we can assume that it's 9, alright? Then there's B and C. And then there's a sum equals to the sum. Her age equals to the sum. So equals to 1 because we know it's 1. And A is the hundreds, B and C. Got it? Okay. Okay, we know that A has to be 9. Okay, so this equation here, I think there's a, you can see that is equals to 2 minus 1000, right? Then you bring the 1 across, become minus 1. So this one, this side equation gives you 1001. Okay, then because there's a minus here, so all this here is minus. So you want to make it positive, you bring this across. So you have A plus B plus C plus 100 A plus 10 B plus C, right? So you have 101 A plus 11 B plus 2C. Got it? Okay, 101 A 7 plus 2C. Right? Because we know that A is actually 9, should be 9. So we have a digit here as well, right? So we can know that this thing here is actually 909. So we just bring it across. Okay? So which is 92 gives you, so basically 1001 minus 909 gives you 92. Okay, so you have 92 here. So just simplification, you have minus 2C divided by 11. So basically how you get this step is simply you have 92 equals to 11B plus 2C. Right. So you have 11B equals to, okay, so what you get down here is 11B, so you have 32 minus 2C. Then you have 92 minus 2C divided by 11. So you have B, this. So you get this answer here. So you know that B has to be a whole number, right? It cannot be a decimal place, right? Because anything that divides by 11, okay, that means there must be a multiple of 11 is what? 22, 33, 44. So you want to get 92 minus something. So let's try 2 here, right? So 92 minus 2 times 2, which is 4. So you have 92 minus 4 gives you 88. So 88 divided by 11 gives you 8. Right? And you know that C is 2, then B is 8. So you have B equals to 8, C equals to 2, and then you know that A equals to 9, so it will be 1982. Right? And you have 1982 add up to 20. Right? So if you look at this, 2002 minus 182 gives you 20. So she's 20 years old. Right, she was born in the year 1982. Okay? Because this 1 plus 9 plus 8, okay, plus 2, it gives you 20 as well. Okay, we satisfy the equation, the condition whereby all the sum of 4 digits of the year she was born in is her age. Okay, so this is the end of the tutorial on whole numbers. I hope you liked the video. Please give a thumbs up and like the video below so that it can inspire me to produce more similar videos for you. Alright, I hope you like it, and it's a bit long, but I hope you learned something out of it. Thank you.